What's up, everybody? Got another video here for you. We're doing some growth and decay problems. This is a decay one. Now let's get started. It says a fossil contains 25% of its original carbon-14, which has a half-life of 5,730 years. The decay model is A of t equals A naught e to the negative kt, where A of t is the amount remaining after t years. How old is the fossil? So let's just start out by writing down our function. All right. Now it tells us that the half-life is 5,730 years. All right. So what that means is if we plug in 5,730 in for t, that's going to give us A naught e to the negative 5,730 k. What we have to do here is we've got to figure out what k is. That's what we're solving for. And if we plug the 5,730 in for t, we should get half of the initial amount. So half of the initial amount would be half of A naught. Well, how do we know A naught is the initial amount? Well, remember the initial amount is the amount present at time t equals 0. And you can verify that A naught is the initial amount. If you take A of 0, if we plug 0 in for t, that's going to be A naught e to the 0. Negative k times 0 is 0, which is A naught times 1, which is A naught. So A naught is the initial amount present. And then if we plug 5,730 in for t, we should get half of this initial amount, so half of A naught. All right. So you see this equation here? We can solve that for k. So if we take A naught e to the negative 5,730 k equals half of A naught, well, we can divide both sides. Now let me change colors. We divide both sides by A naught. See, this one and this one cancel, that cancels, and we're left with e to the negative 5,730 k equals 1/2. And we can solve this for k. We have an exponential equation. Okay. So if we take the natural log of both sides, all right, this is going to give us negative 5,730 k equals natural log of 1/2. All right. So the thing you might be wondering is what happened to the ln and the e? Well, this goes back to properties of logarithms. Remember, the log of b to the x with base b is equal to x. If the base of the exponent and the base of the log are the same, then your answer is just your exponent. And then we also know that natural log of x is equal to the log of x with base e. So basically, this log base e, instead of writing log base e, is like we're abbreviating it ln. Okay, so ln is the same thing as log base e. And what we have is the natural log of e to the negative 5,730 k, which is the same thing. ln is the same thing as log base e of e to the negative 5,730 k. And since the base of the exponent and the base of the log are the same, you just get the exponent. That's where that comes from. So now we're going to divide both sides by negative 5,730. And so, whoops, let me go back to the different color. So we get K is equal to, so that's going to be natural log of 1/2 divided by 5,730. And so we are going to get negative 0.000120097. Okay, so that's K. So now we can write, we can write our function as a of t is equal to a naught e to the negative e to the, that would be a positive 0.00, because that's a negative divided by a negative is a positive. Well, that should be positive. So that's going to be negative 0.000120097 t. So all I did is this right here, what I found for K, I just plugged it into there. Okay. So this is our function here. Now what do we want to know? We want to know a fossil contains 25% of its original amount. So we know the original amount is A naught. And what would be 25% of that? Well, that would be 0.25 times A naught. Convert the 25% to decimal, so that'd be 0.25 times A naught. That would be 25% of the original carbon-14. So we want to know when does A naught e to the negative 0.000120097 t, when does that equal 25% of the original amount? That's what we're looking for. We got to solve for t. All right. So we're going to divide both sides by A naught, and see the A naughts cancel. And we're left with e to the negative 0.000120097 t is equal to 0.25. And now to solve this, we're going to solve this just like we did this one up here for K. So we're going to take the natural log of both sides. And so that's going to give us negative 0.000120097 t. Remember, we discussed this earlier, how we just get the exponent. And then we're going to divide both sides. And so we get t is equal to okay, so, I don't know if your teacher might let you leave it as an exact answer. That would be that. But if you plug it into your calculator, we would get 11459.8 years. And there's your answer. So 1, 2, 3. So almost 11,500 years it would take it to get to 0.25% of the carbon remaining. All right, so I hope you enjoyed that video. Hope it helped you out. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.